Welcome to the Notes on Radicals. Today we're going to be discussing square roots and perfect cubes. So, a quick reminder, remember that what does 5 squared equal? Well, 5 squared equals 25, right? Because 5 times 5 equals 25. All right, so today we're going to learn about a radical, which is this symbol right here. Some people call it the square root, but it also could be a cube root, which we'll discuss as well. So then remember, the square root of 25 equals 5, because 5 times 5 multiplies to 25. So the square root of 25, we would say, is 5, and that would be 25 would be a perfect square. And remember, it could also be negative. All right, square root of negative 25 equals negative 5, because remember, the red, negative 5 times negative 5 equals positive 25. So just kind of keep that in mind as well. So we're going to get right to it. Here are some examples. Okay, you can use your calculator if you want as well for these, which not a problem, which is perfect. All right, so the first one, A. All right, let's kind of do it right here. A, the square root of 36. Okay, so A, square root of 36. Put that in your calculator. All right, that equals 6, all right, because again, 6 times 6 equals 36. That's why the answer. Okay, B, all right, what's the square root of 0? Okay, well, type that in your calculator. You're going to find that it is 0, because 0 times 0 is 0. Now for C, all right, the key to this, all right, is to rewrite. That's really the square root of 4 over the square root of 49. When you write it like that, it's a lot easier to see. Well, the square root of 4, that simply is 2. And the square root of 49 is 7. So the answer is just 2 over 7. So rewriting that radical sign to both numerator and denominator. All right. For D, I'm just going to have you use your calculator. That's the square root of a quarter. All right. If you take the square root of that, all right, you'll get your answer there. That's just a calculator problem. We don't need to discuss that much. All right. Now E. Okay, right here. All right. How do I take the square root of x to the 6th? So remember, all right, if I have x squared, a square root will cancel out and it'll equal x. So the way to remember is we're going to divide the exponent by 2. So we're going to divide by 2 because there's really an imaginary 2 here. So if I have x to the 6th, so I'll do it right, I'm going to scroll down just a little bit. All right, if I have x to the 6th and I take the square root, well, you're going to ask yourself, 6 divided by 2 is 3. So this is going to equal x to the 3rd. Again, x to the 6th is really x squared times x squared times x squared. So for every 2, I can take 2 out. 1, 2, 3. That's how I get x to the 3rd. All right, because that would be x times x times x, which would give me x to the 3rd. All right, that'll be important. All right, F. All right, 9x to the 12th. Well, look at the 9 first. The square root of 9 is just 3. And then x to the 12th, I divide by 2, that's going to be x to the 6th. All right, G. Notice the difference between G and H here, right? We're going to focus on these two. There is a big difference here. All right, G, all right, that answer would just simply be negative 9, right? Because negative 9 times 9, negative 9 times negative 9 is 81. All right, here, H is going to be no solution, because the only way to get a negative number is to have negative 9 times positive 9 equals negative 81. These are not the same number. So that would be why it's no solution. You can't have the same sign and multiply to a negative. So there's square roots. Let's go on to the back. All right, now we're going to talk about perfect cubes, all right, or cube roots. So what times itself 3 times? So again, x times x times x has to equal, all right, would have to equal x cubed. All right, so what would be a perfect cube? So we look at the first one. What times itself 3 times would equal 1? All right, so in this case, all right, that would just be 1. 1 times 1 times 1 equals 1. So it would just be 1. Now, negative 64, okay, what multiplied 3 times would equal negative 64? Well, that would actually be negative 4, all right, because, take a look, negative 4 times negative 4 is positive 16. Well, positive 16 times another negative 4 would give us negative 64. So negatives are okay under a cube root. Again, and you'll notice it's a cube root because of that 3. For C, we're going to rewrite it, so it's the cube root of 8 over the cube root of 125. So cube root of 8 would equal 2, because 2 times 2 times 2. Cube root of 125 is 5. All right, 5 times 5 times 5. Those are perfect cubes. D, all right, now, again, if I have an x cubed, a cube root would cancel that out, and it would just give me x. So I'm going to divide 6 by 3. So 3 divided by 6 is 2, so that's x squared. All right, no longer under the radical. Here, let's do the numbers first. Negative 27. All right, that's a perfect cube. Negative 3 times negative 3 times negative 3. So again, negative 3 times negative 3 times negative 3. So it's negative 3, and I've got an x to the 9th here, so divided by 3, it's x to the 3rd. There would be your final answer for that one. So there you have an introduction into radicals with square roots and cube roots.